Hello everyone. Today we are going to talk about scalable apps. Apps which every one of us wants to build. Lots of customers, lots of user, lots of traction, great user generated content, right? Now, what is the magic juice behind all these applications? This is what we are going to dive deep in our second part of Scale Up, Don't Screw Up series, where we are utilizing FlutterFlow and Firebase capabilities, the power of these two uh, platforms, where FlutterFlow is a no-code platform. We want to use the power of this no-code platform to build enterprise-grade scalable applications which can serve a lot of users. So, just in case you have missed the video one or chapter one of this series, I'll drop the link below this video in the description that you can later on view to. All right, so let's start with a question. What does it actually take to build these scalable apps? Now, for instance, if you have an app with five monthly users and it costs you $5 that you pay on a monthly basis, how much would it actually cost you to have an application which has 50,000 users on a monthly basis? This is a simple math. Now, if you're going to do it right, straight out of the box, simple mathematics, arithmetic way, the answer would be $50,000. Now, isn't that too expensive of a system to actually maintain? Now, as we all know, when it comes to manufacturing, when you manufacture things at scale, when you purchase things in big volumes, you always get a discount, you always get a lower price, right? So, just like how it works in the physical world, likewise in the IT ecosystem, if you have five users and you're paying $5 a month, just because you have $50,000, you are not going to pay $50,000. So the answer lies somewhere on how you start optimizing for this scale, correct? So if you ask me, the essence of scalability is derived from various parameters. So I broadly broke them down into five different parameters. The first parameter being efficiency and optimization of what you serve. So how efficient do you serve your content to your users? How optimized is it? With takes into billing, etc., into consideration. So how optimized are you able to deliver this content in an easy, efficient manner? That's what defines how much you're going to spend. The second parameter is what is the security that is needed? What is the redundancy? Scalable apps need to be very secure for people to trust and keep using them again and again. They need to have a lot of redundancy, a lot of backups. So just in case people end up deleting their data, they should be able to recover it. So you need backup. You cannot directly go delete that from your database and forever lose access to it. Third thing about scalable applications is it needs to be stable. It needs to be easy to maintain. It needs to have constant maintenance. So you need to find it very easy, low cost maintenance, right? So whenever you buy a product, you always ask, I buy a car. How much does it take on a monthly basis for me to maintain? Is it cheap? Is the spare part cheap? Just like that, in the IT system, in the world of app development, maintenance cost matter. Third, upgrades. What does it take to upgrade to a new version? What does it take to upgrade, add new features to my apps, right? And how much all these patches tally to. And that is another essence of scalability. Now, the fourth dimension that we have to take into consideration is what is the compliance? What is the cultural significance? Now, compliance basically means rules and regulations that govern a certain geography that you operate in, that you do your business in, that your app has to comply because you're dealing with user data, you're dealing with their private information, personal information, etc. And of course, the app and Play Store regulations set forth by Google and Apple, where you actually go ahead and deploy these applications if you're doing mobile apps. Now, cultural significance, why? Because customer demography matters, the cultural impact matters, and if you do something cross cultural where you end up adding a feature which is not in alignment with the culture of the target market, it might actually fall flat. The fifth being finance. How much money does it actually take? Do you actually make money by doing all this? And what is your actual product which is going to make you money? Is it the features that you show to the people, or is it a derivative that you are able to derive something meaningful with which you are able to monetize? So, we are going to actually break an app down into these five broad structures or five broad parameters or categories to really understand how we are going to plan our entire architecture of the application and make it scalable. So now, with that said, let's flutter flow. So as we discussed in part one, we are going to start our understanding of building scalable applications using this ready to use available application from the FlutterFlow template repository called the Sniff Social, right? So this is how the template actually looks like. This is the homepage which I actually made a copy of. So the first thing that we are going to understand is what all kind of impacts our the first parameter, the efficiency and optimization. So let's just quickly review through the basic structure that is already part of the template, and where a scalable application might slightly differ, so that it becomes very clear from the perspective that we are going to approach, right? So the first thing is we see a feed. So we see a social feed, so that basically means we are going to see list of posts by all the users, other users, our friends, etc. So let us just look at the backend query. Now when we go through this backend query, I open this query and click edit backend query. I am seeing that the system is querying a collection called user post, and it is getting a list of documents where the limit is set to 50. So each time this query makes is done to the backend, the database or the backend is going to return us 50 user post, right? If there are 50, it's going to return as 50. If there is going to be less, it's going to return as less. But if there is going to be more than 50, it's going to return as 50, right? That's what this limit actually means. And we are basically passing something saying order by decreasing of the time posted, which is basically show the newest post first. That's what it actually means, right? So now it's going to actually give us 50 documents. So that means we consumed 50 reads. That means we consumed 50 reads from our Firebase billing cycle, monthly billing cycle. Now, the moment we query that, there you see that there is one more query that is being added, which is taking into consideration or which is querying document from reference from the user collection, and which is actually passing the user reference from the post user parameter, and this post user parameter is coming from the user post document. So what they are actually doing is they are querying for first for the post, and once the post document has come to the UI, the UI is going to make yet another query to the backend on every single post, right? So if there are 50 posts, it's going to make 50 into 200 queries to the backend just to get the user information of the person who has posted this, right? So that basically means that this section alone will take 100 document reads. I'm not even talking about these likes, comments, and shares or whatever. I'm just talking about the basic feed. Without you interacting with it, it's going to cost us, only this feed is going to cost us 100 document reads from our database. So if each user is going to access it, it's going to be 100. So multiplied by a scale of 50,000 users that you want to have, that is 50,000 into 100, correct? That makes it what, 500,000, and then 5 million reads from the database, right? That's a significantly large number. Now just by doing a simple tweak, we are going to look at advanced tweaks, but just by doing a very simple tweak where I go ahead and as and when in the user post collection, if I'm able to store the user name and user image which I've added, right? Now let us take a look at an optimized version of this page where I have removed, you see, I have removed the second query, and I am able to directly render the user image and the username right from the user post query, because I am storing in the user post query the name of the user, the image, the profile picture of the user, so that it will be easy for me to render and I am avoiding one query, right? So this basically means that I am already optimized by 50%, because every post needed two queries, but now it needs only one, correct? So I have already reduced my billing by 50% just by doing a very simple hack. Now, how is this act even possible to be done? Right? So, this is not something that you start thinking from this page. The solution, if you are going to think only at this page, is going to be to add one more query. Right? But if you actually start thinking where this post originated from the create post page. Now, in the previous video, I had emphasized again and again on this factor where I say that whenever you create or an update a document, that's when you have maximum contextual data of the event. So if I want to go and record or create a document in this user post collection where I want to record further information like the user post name. Correct. So I will have access to the authenticated user because the authenticated user is the one who is posting it. And you see, I have access to their display name. Correct. And you also see when I want to record, I also have access to their user image. Correct. From the same authenticated users current document. So whoever is authenticated, when they are going to make a post, I am storing their user image and their username as they create the post. Now, if I leave this, then what do I do? Either number one, my first option is I'm going to add one more query to the backend on every single post where I am storing a reference, or I'm going to write a cloud function on the backend. I'm going to write unwanted code to go fetch this document on the backend and store it along with this document if I don't store it from the UI. Now, why would I want to do it? If I knew that I need this on my UI, I should create this and I should store that contextual information that is needed for me, which is going to save 50%. I repeat, 50% of my usage on one page. So, if once again you fantasize building an app for 50,000 users, right? You then every query, every user is going to see 50 documents, that is 250,000 or 2.5 million, let's say, whatever be the calculation. And then you are talking about two queries, and then if that is divided by two, that's a significant saving on your monthly usage that you could actually do, right? So this is what we mean, that if you are able to foresee what you actually need to render on the UI and start planning your writes and updates as we spoke about in video 1, you will be able to save down significantly on your billing as you progress, as you scale. And this is what optimization is, and this is what efficiency is in delivering the content. Now, a lot of people coming from the SQL world know or talk about storing references and references alone and doing joins, etc. Now, let me give you a bit of a comparative understanding with regards to what we are dealing with here. Now, back in the day, when database came first into existence, you would have noticed that you had hosted this SQL yourself in a server, etc., where storage really mattered. When databases first came, storages were expensive. But these days, when you create, let's say, a Gmail account, you're getting a cloud storage for free, right? You're literally getting something for free, 15 GB for free, and the storage is way too inexpensive. So let us think of it this way. Once we go into cloud ecosystem, cloud computing, quite a lot of these costs come in transactions. By transaction, basically I mean is bandwidth. By transactions, I mean is exchange of data. I seek some information, the server returns or the database returns certain information, that's when I actually pay more money. So if you are able to create redundant structure by storing the username once again in the post collection, by storing the link to the user image once again in the post collection, you are able to actually, this redundancy is able to significantly lower down the amount of calls or transactions that you are making, right? Which makes it scalable. The second aspect of what this redundancy actually does, let us look at it from another aspect of build building enterprise grade financial applications where you are recording, let's say, transactions, or for instance e-commerce where you are recording certain transactions. Now, for instance, today I have a display name, or I set a username named Kaushik in my profile, and you are only storing a document reference of my profile in an invoice, in an order generated. So you are saying that this order was placed by this customer. But for instance, if this customer is going to change their display name today from Kaushik to, let's say, some other name, say Anne or Finn, right? Now, what basically happens is whenever you are going to render that order document, which was even generated in the past, in some future date where somebody wants to access the past records, if you are going to real time query for the user document, hey, you are going to see a brand new name, but whereas a transaction was done in a completely different name. So a transaction that was done in the past cannot be changed or cannot be modified, because this is something that you need to make sure that it does not change for auditing, logs, compliance, etc. So redundancy is very essential for safety, for security, for compliance, for audits, for traceability, for accountability, for finance, a lot of parameters. So don't think just by storing references and references alone, you have an optimized system. No, references doesn't mean anything. It's all about redundancy, where you are able to maintain data sanity, data cleanliness, and you are able to bring about accountability, you are able to bring about audit, you are able to bring about transparency, governance, compliance. That is what is an essence of scalable application, right? So redundancies are sexy, are must to have. The third thing that we are going to talk about is stability, is ease of maintenance, is upgrade, is patches. So by this, what I actually mean is, whenever we do any sort of designs, like back in the day when API calls were the thing, even now a lot of applications are built on API calls. But whereas a Firebase and FlutterFlow integration is not really an API call, is more of a real-time socket connection. It's an SDK integration with real-time capabilities. So something that, but API is never real-time. APIs are, I request something, I get a response, and then the connection is closed, and then I have to open the connection, request something, and I get a response, and then the connection is closed, right? But here, when we are dealing with Firebase and FlutterFlow, this is a real-time sync. So whatever is on the database, in theory, reflects on your UI on real-time basis. There is a real-time communication that happens between these two platforms. Now, when you are dealing with a real-time platform like this, back when you design things with API, what actually happens is I hit a API call, and then the magic controller or the server is basically whoever wrote the API call. This is the scenario that they will be dealing with, saying, okay, I'll put all the business logic, the formula, I will do the SQL joins, I'll go fetch from this table, that table, and join, pull together one data, pack it as a JSON, and send it to the UI. So you are doing quite a lot of these permutations, computations, and computations on the fly. But if you really want a stable maintenance system to maintain, upgrade in an easy manner, you need to drive quite a lot of predictability in what you're going to do. So by predictability, what I mean is, if I know that a particular user is going to click an order button, or when they click an order button, I am going to show them a list of orders which has already happened in the past, right? So why do I need to yet again do computations on the fly? Why would I need to yet again do joins on the fly? But if I actually store this data as a flattened structure, as a hard written copy, as a contract which is etched forever in a piece of paper that cannot be manipulated, or the fancier days, these days, today you call this technology as blockchain. But blockchain has been existent. That concept of technology has been existent for ages, right? Where you etch something on a piece of paper, you carve it, and you cannot forever change it, right? So now, if you follow these practices and you write to a collection where the customer name was frozen, where the time a certain event happened was frozen, the order value was frozen, the product name, the quantity, everything was frozen, it was written, hard grained, then what basically happens is you are not doing any computations to show past historic events like orders, which are already over, immutable, it cannot be changed. Then it becomes very easy for the system to just take something and directly dump it as a data dump onto the UI, right? So you don't really need to introduce new formulas, new computations, and waste your resources when you are thinking about building scalable systems. And when you actually lower them down, you will notice that you have moved your error from front end having error, back end having error, to only the back end having error or the API call having error. Nothing else on your system can actually have error. So if you notice that the database has certain value and it is reflecting on the UI, so you know your UI is never wrong. So even debugging becomes very, very easy. You park it always towards one source of error and only one source of error. And this is an essence, a foundational essence with which scalable systems are built. So our core strategies that we are going to cover as we move along this course is how we are going to align our business and technical needs, how we are going to align the market requirements with technology specifications, how we are going to derive a return on investment on every single feature that we are going to add to our application. If we are going to do a like system, what are we going to derive from this like system as an organization which is going to yield us money? And we are going to prioritize and compromise. We are going to take in some features which are going to yield us the revenue, or which is going to give us that business edge with which we are able to scale, and we are going to compromise on certain features early on which might not be relevant, which is good to have but not really must have, or what are those features which are stick to completely avoid. So these are the foundation or the strategies that we are going to be talking about in alignment with Firebase and FlutterFlow as we move along in this course. So once again, thank you for watching this video too. I really, really hope you enjoyed. And in case you have any requirements where you want to discuss about your mobile application, web application development with FlutterFlow, this is my email that is listed. I'll also add it to the description of the video. Once again, thank you very much for watching. Stay tuned for the next one.